Test tomorrow. How can you check to see if a function is a one-to-one function? So that's how you ask if I don't think it's right there. So you can check for a horizontal line test. What do you test to see if it's just a regular function? Vertical line test. What does every inverse graph, what is it reflected across from the original graph? So it's reflected the y equals x line. I'm trying to think about other random things to graph. What about sine and cosine? Could you graph and tell me the domain and range of sine function with its restriction and its inverse graph? Sine, cosine, and tangent. Could you do those?
Maybe not tangent.
Well, let's. So y equals sine x.
Oh yeah, I do remember that.
Y equals sine x. What are we graphing? Where does it start? Where does it end?
It starts at 0, 0.
Okay.
And then it goes up to pi over 2.
Okay. So maybe pi over 2, 1. That's another point. So we're going to pi to 0. This is the graph that you're going to do the inverse of.
Oh, wait.
If I go over to pi 0, is that a one-to-one function if I do this?
Oh, no. Okay, I thought you were just asking for a sign.
I do not want the sine graph.
Okay.
I want to know the restriction that it's going to have.
Then negative pi over 2,
Negative pi over 2, negative 1. Do I expect graphs to be labeled?
Yes.
Most definitely. Okay? So this graph goes up like this, goes down like that. That is y equals sine x. What is its restricted domain and range? What is the restricted domain and range? What oh my goodness, I almost
Negative
called.
pi over 2 is less than,
So the domain is what?
Negative.
Oh,
Wait,
no.
Parentheses or
XCER.
bracket.
Line.
Bracket. No, not set.
It's X.
Is there
It's
a
a
double
set
R
of all real numbers, such that
Negative pi over 2. Is less than or equal to X.
Less than or
Less than or equal to
pi
pi
over 2.
Okay. What is the domain? Sorry, what is the range?
Your
Y is a set of all real numbers such that
negative 1 is less than or equal to y. Less than or equal to 1.
yeah.
Your
Can you graph the inverse function? Let's go ahead and graph y equals sine negative 1 of x. Could you tell me the domain and range of the inverse function? Do you want to graph it? Doesn't matter. So the domain will be the range of the original. So x is a set of all real numbers such that it's between negative 1 and 1. We took this range is now the domain of the inverse function. What is the range? Bless you. is the set of all real numbers such that y equal to pi over 2. What does that graph look like? Over to 1, up to pi over 2. Origin 0, 0. And then flip the curve, go that way. Okay. You see how similar these graphs look? If they're not labels, I will not give you credit. Okay? Because they almost look, I mean, they've got the exact same area of 3 dots in the same spots. Okay? The curvies, is that what you said? Yeah. This one's going to curve around the y-axis. This one will curve over the x-axis. Okay? Sine and cosine is in the back, so it's not that terrible. What about cosine? Could you do the original and inverse for cosine? You ready? We'll do it just in case. Draw our 2 graphs. Alright, so cosine. Where does cosine start? Where do we want to graph cosine? What's our domain and range of our restriction? Is it again negative?
Nope. This one is
0.
pi is
0, 1.
Yep.
Pi over 2, 0. Oh, I didn't. We go over to pi and go down to negative 1. So, what's our domain of cosine? Do we write this one in interval notation?
No,
Oh, wait, is
do
it
start.
Yeah, do.
Interval notation. I don't think there's dots, but is it a bracket? I don't know.
It is a
Why would it be a bracket instead of a parentheses? Because it equals the domain. Our inputs, what are we going to? 0, 2, pi. Does it equal each of those?
Indeed.
It does. It's actually going to equal pi. And it's actually going to equal 0. Okay. What about the range? What?
Bless you. Well,
It's going to curve like this, like it would go down like that. And like it would go up like this.
The range is bracket. Negative.
If you have us like fill in the domain range, which way are you gonna do it on the test?
I'm doing it both ways, so maybe you would know how to do it both ways.
so we have to know insert your and this.
So this is so much easier.
I mean, it's not a problem.
It is a problem.
Hey,
John.
what
noise does a
For yourself.
Alright, what about the inverse? Y equals cosine negative 1 of x. What is the domain? In the range. What does our graph look like? The point that was 0, 1 becomes what?
1, 0.
1, 0. the point that was pi over 2, 0 becomes, I probably should just
0 pi over 2.
scoot this whole thing down. Or not.
How does it know what this is?
It just takes whatever I drew close to it and picks it together. Alright, so 1, 0, 0 pi over 2, and then negative 1 pi. Where does this graph go? It's going to go like it's curving around the x-axis. It would be curving around the y-axis. Okay? What about tangent? What about tangent? Y equals tan x. What are the do you want to give me the domain and range first? Because you're looking at your notes.
Let's
Do
get
you,
let's-
I'm just,
the
do you
range,
know
the
them?
the domain first.
These are the.
We do the.
Or
is it
the point.
inset? Is it set and bracket?
I don't know.
Like is that what they're the two that are called? The one that's
There's
not
set
set
notation, and then there's interval notation.
Let's do interval notation.
You don't even know what it's called. You're not allowed to do that.
But it's the one we just did for cosine.
Is it interval the bracket?
Yeah, interval's the simple one.
Do you want to give that to me first before we graph it?
We can do set for the range.
She didn't ask that.
Alright, so where does tangent start? What does the tangent graph look like? There's some asymptotes. Where? Pi over 2 and negative pi over 2. So there are asymptotes here. Means it's never going to touch it. What about tangent of 0? 0. What about tangent of 45 degrees? So if we were doing our quarter periods, this would be a pi over 4. What's tangent of pi over 4? 1. What about tangent of negative pi over 4? Negative 1. That's just 45 degrees or negative 45 degrees. What happens is it's the only one where I plot other points in between our domain. Yes.
Did you ask a question like that I can answer? Like, are you asking mine to grab it now? Like, what happens when you grab it?
Sure. I don't know what I asked. You just raised your hand and I thought you had a question.
Oh, no.
So what are we doing when we graph it, John?
So it goes like along the asymptote, but it never touches it.
Okay, so it actually goes up to this pretty slow and then jumps to infinity.
And then it's
The inverse way, and then it goes down to negative infinity. Do you know that on the other side of the asymptote, it's a new period, and across the asymptote, when we're going to positive infinity, we jump to that next quadrant. It's negative infinity and comes up. Okay. In general, you won't ever see an asymptote and things coming from the same infinity, like negative infinity or positive infinity. Sorry, I'm stuck in other worlds right now.
Do you mean that'll come from
Like it will, like if it's going up to positive infinity, on the opposite side, it would come from below. And that is almost every time you see an asymptote. 99% of the time, that's what's going to happen. It would come from below here. Why is that not right? Okay.
Guess we have to recalibrate.
Oh no.
Like it would come from below below. So, what is the domain? What is the range? Let's do set. X is the set of all real numbers such that
Negative pi over 2 is less than.
is it equal to?
Absolutely not. No.
Pi over 2. What is the range?
Y equals your.
Y is a set of all real numbers such that. Is there any restrictions on the range? Oh,
That's crazy.
the set of all real numbers. No restrictions whatsoever. What would this look like in interval notation? What would the domain look like? John.
It would be open parentheses pi over negative pi over 2, comma pi over 2, close parentheses for the domain. And
Okay.
the range would be open parentheses negative infinity, comma infinity, close parentheses.
Okay. Because tangent will not touch its domains or ranges, we have parentheses on all of it. Okay? Because there's no equal sign. Never gonna touch. Let's do inverse tan. Why did I do that in parentheses? I don't know. I'm sorry. What does this graph look like? Do you want to go ahead and do the domain and range first? So the domain. Let's go ahead and just do it in interval notation.
Those are really sad things.
Negative infinity to positive infinity. What is the range? Yeah, if we're doing it in interval, then we would just use parentheses. Set is the y is the set of all real numbers. Negative pi over 2 to pi over 2. Sorry. Alright, so what does this graph look like? Domain and range. Domain, everything.
You're asking
Range, what are we going up and down to?
asymptote pi over 2 going horizontally.
And
And at negative pi over 2 going horizontally. And then
pick your point.
0, 0, you know that. And then pi over 4, 1.
So is it pi over 4, 1?
No,
Or
it's one pi over 4. My bad.
Pi over 4.
And then negative pi over 4, negative 1.
Or negative 1.
Yes. Negative 1 pi over 4. No,
Oh, really not nicely drawn to scale. That negative 1 is really far away. Okay, so this technically goes here, and then woo! Get close to the infinity line. And we go here, we're going to pretend it touches that dot. There we go. We have flipped it.
So I will pick up all of that if you go to move that.
Move what?
That whole graph.
I mean, and sometimes it wants me to outline what I want.
Oh, okay.
Oh, and it wouldn't let me just do the whole board. So, like, I obviously was too much, and it was supposed to move the whole thing. All right, those are basically all of 6.1. Sine, cosine, tangent, having those restrictions, and being able to graph. If you see the word arc tan, what do? Or arc sine?
That's the inverse.
So if you see y equals arc sine of square root of 3 over 2, what would you do to solve for y?
Is it 2 over square root of 3 over 3? Yeah.
Let's think. Do a little bit more. What is this really asking for? Is the biggest question. What is this really asking for? Could I rewrite this some way? How? Sine y equals square root of 3 over 2. This is saying what angle sine gives me the square root of 3 over 2. So how do we find that? If I ask you for what's the exact.
Oh, we can use our triangle.
Should we draw a triangle where the opposite is a square root of 3 and the hypotenuse is 2? And this is our theta. This would be a 1. This would be 30. This would be 60 degrees. Okay, so what would my answer be? 60 degrees.
Yeah, would it be?
Yeah, do you just use that as a reference angle, or is it
Now, the question is, we just did domains and ranges. If I'm asking for an inverse sine, where it's just this problem, it's saying which one falls in my domain or range. Okay, which one falls in my range of my inverse function, my one-to-one function. Okay, so oh my goodness, 120 fall into that range? We just did domains and ranges. Because it's from negative 90 to 90. Okay, this is the one that we're going to go with the answer in our calculator. Because it knows best. Okay? The only time we're not going to is when you're given a 0 to 360 or a 0 to 2 pi. Okay? That was really 6.2 when we solved equations. So we need to solve an equation where there were multiple answers. So it's like, feels like we just did this, but we've had a weekend, right?
We should do it again.
We probably should definitely do it again. Let me first some other ones that we haven't done already. What about, I personally would go back and look at my notes, the ones we did last week.
Happy birthday, Dr. Seuss.
Yes, happy birthday, Dr. Seuss. I want this one.
Six.
Between, wait.
I got it.
Yep, I do.
Okay. Solve each equation for exact solutions over the interval from 0 to 2 pi. Are you thinking, can I factor this? If that's not your first thought, we need to refresh greatly on quadratics. What factors? If you have an x squared plus 2x plus 1, only two things are going to multiply together to get cosine squared. Only two things are going to multiply to get 1, right? 1 times 1 is the only thing that's going to give me 1. Cosine times cosine is the only thing that's going to give me cosine squared. Okay. Next, everything is positive. So what should be in between these?
Plus.
A plus. What are you going to do next?
Set each of them equal to 0.
Do I need to make 2 equations for this? No. Why? They're the same thing. Somebody might even write cosine x plus 1 squared equals 0. And you take the square root of both sides. The square root of 0. 0. So you're only going to have that 1. Okay? When you set it equal to 0, let's solve. How do we solve this? Cosine x equals negative 1. So where do we look up there and find a negative 1 for cosine? At 180 degrees. It's the only place. So what is our answer? X equals pi. Is there anywhere else that's going to equal negative 1? No. Not in our interval. Not for another 360 degrees. I think probably the hardest part of this is knowing how many solutions. So we could have 1 solution, or some of them might have 4 solutions. So let's look. Oh, they already factored that. That's not nice. Okay, let's do one more that has multiple solutions. I don't know that I like this one. I just went to find. I looked at the solutions before I looked at. No, let's don't do this one. I'll do a different one. But I don't like that. They already have it. They already have it factored for you. Obviously, because we need help sometimes factoring, right? Cotangent x minus 1. Square root of 3 cotangent x. This is a nice one. Plus 1 equals 0. They went ahead and factored it for you, though. Bless you.
Wait, is there supposed to be another parentheses after
Oh, sorry, after the 1. So if they've already factored for you, what do you do? Oh, wait, I need between 0 and 2 pi. You set up 2 equations. At the end, did we get to this point? Cotangent x equals 1. Cotangent x equals negative 1 over the square root of 3. We all get to that point? What are you thinking? What's your thought after you get to this point? Draw a triangle. What else? Could anybody ask, what's tangent?
Yeah.
I mean, maybe. Here, we go to the side. What is tangent x in this case? If cotangent is 1, what is tangent? When we take the reciprocal, it's just 1. right? What's tangent in this one? Negative square root of 3 over 1. So if I were to draw my triangles, which triangles would I draw?
45,
45, 90 that are 1, 1, square root of 2. And this one over here is a 30, 60, 90. Square root of 3, 1, 2. Okay. So what am I looking at now? Is this all I need? My answer is 45 degrees, right?
No.
That's a reference angle. Is that one of my answers?
Yes.
Yes. Just like 60 degrees over here is, oh, it's not one of my answers. But what do we need to be looking at?
Where tangent
Well, I mean, also in
Where
the
tangent-
one on the left, it's where is tangent a
Positive.
positive one.
and the other one's where tangent's negative.
So I need that 45 degrees. What quadrants is tangent positive?
No. Negative.
1 and 3. So what is my reference angle? You've got a plate. So x equals. When you're looking at quadrant 1 and quadrant 3 for 45 degrees, what is your x equal? Looking at your plate, quadrant number 1, quadrant number 3, pi over 4 and 5 pi over 4.
Will you specify on the place if you want radians, or should we just leave it? Oh, yeah.
When you see that, that's going to tell you.
Yes,
So yes, there's a section that has that, and there's a section that has 0 to 360. Okay? But now we need to know this one, 60 degrees. What quadrant is tangent negative square root of 3? So we're in the second quadrant and the fourth quadrant with our reference angle of 60 degrees. So what, looking at my plate, second quadrant 60 degrees, x can equal what? 120, but in radians? 2 pi over 3 and 5 pi. This one has 4 answers. I don't think. There is one that may have decimals though, so I'm trying to look. Say what?
Do you like have us write out the quadratic formula for a bonus question? Because I mean we touched on this in chapter.
We did. This one is a nice decimal. I don't like giving you problems that I didn't do. It's going to be raining for the next 3 days. Why?
We're supposed to have a track.
It's not going to rain on Thursday, I don't think. It's going to be raining up until you get to that point.
Yeah, I don't ruin the field.
See them on knee pads. I already plugged it in
Do what? 0 to 360.
What else would? Whoa there, Buckers. Everybody calm.
See this line? Yeah, the cross.
Yes. Do what? Cosine. I don't give you one that's hard. I'm just thinking I probably shouldn't have given this to you. I won't give you something that has both of them in it
Miss Evans.
to solve for it.
It's like, I don't know what to do.
So it's subtract two cosines and factor two out. But
You keep the one on the other side. Oh, no.
I would. Yeah. I wrote that one down and then I realized, all I was doing was looking for decimal answers.
Wait, she subtract.
I know. Just add.
I feel like a five.
See, we didn't have,
Okay.
You didn't have it. John, aren't you out for getting
Just a second.
things?
Let me stop.